Picture this. You're standing on the surface of Mars, but instead of a barren, rust-colored desert, you see rolling green hills, sparkling lakes, and a sky that's not pinkish red, but a soft, familiar blue. You take a deep breath, no spacesuit, no oxygen tank, just fresh, clean air. This is the dream of terraforming, transforming Mars from a frozen, lifeless world into a second Earth. But is this even possible, or is it just science fiction? The truth is, the idea isn't as far-fetched as it sounds, but the challenges are enormous. And the journey would be one of the most difficult projects humanity has ever attempted. Mars is, in many ways, our best shot at becoming a multi-planet species. It's the most Earth-like planet in our solar system. A day on Mars is just 40 minutes longer than ours. It has seasons, polar ice caps, and even evidence that rivers and oceans once covered its surface. But today, Mars is a harsh, unforgiving place. The average temperature is a bone-chilling -80 degrees Fahrenheit. The atmosphere is 95% carbon dioxide with almost no oxygen. And the planet lacks a magnetic field, leaving it exposed to deadly radiation from the sun. If you stepped outside without protection, you'd freeze, suffocate, or be fried by cosmic rays within minutes. So how could we possibly turn this frozen wasteland into a livable world? Right now, Mars's atmosphere is incredibly thin, less than 1% the pressure of Earth's. That's so low that liquid water can't exist. It would instantly boil away, no matter how cold it is. To fix this, we'd need to pump massive amounts of greenhouse gases into the air, creating a thicker atmosphere that traps heat. One idea is to release carbon dioxide trapped in Mars's solar and polar ice caps. We could do this by using giant orbital mirrors to focus sunlight on the poles, melting the ice and releasing CO. Another wild idea: crash icy comets or asteroids into Mars. They're packed with frozen gases like CO and water vapor, which would vaporize on impact and add to the atmosphere. Over decades or even centuries, this could trigger a runaway greenhouse effect, warming the planet enough to melt more ice and release even more gases. Even if Mars had a thicker atmosphere, we still couldn't breathe it. It's almost entirely CO, with only trace amounts of oxygen. On Earth, plants and algae turn CO into oxygen through photosynthesis. So, one solution would be to introduce genetically engineered microbes or hardy plants like lichens to Mars. Scientists have already tested organisms like cyanobacteria in Mars-like conditions, and some can survive and produce oxygen. Over centuries, these tiny lifeforms could slowly transform the atmosphere, making it breathable for humans. Another option is to build massive oxygen factories using chemical processes or even artificial photosynthesis machines to split CO into oxygen and carbon. But no matter how we do it, creating a breathable atmosphere would take centuries, maybe even thousands of years. Earth is protected from solar radiation by its magnetic field, but Mars lost its magnetic shield billions of years ago. Without it, the planet's surface is bombarded by deadly cosmic rays and solar flares. Long-term exposure would give astronauts and future colonists dangerous radiation doses, increasing cancer risks and making it nearly impossible to live safely on the surface. One radical idea is to jumpstart Mars's core, to create a new magnetic field, maybe by running enormous electric currents through the planet or using powerful superconducting magnets in space to deflect radiation. Until then, the only way to survive might be to live underground or in heavily shielded domes. Water is essential for life, and Mars has plenty of it, just not in liquid form. Most of its water is frozen in the polar ice caps or buried underground as permafrost. Melting it would require heat and pressure, which a thicker atmosphere could provide. Some scientists believe that if we warmed Mars enough, the ice caps would melt, releasing water vapor into the air and possibly creating rain. Over time, this could lead to rivers, lakes, and even small oceans. But we'd also need to manage that water carefully. Without a strong water cycle like Earth's, much of it might just freeze again or evaporate into space. Even if we could solve all the technical problems, terraforming Mars would take an unimaginable amount of time and resources. Some estimates say it could take hundreds or even thousands of years, far longer than any civilization has ever sustained a single project. And then there are the ethical questions. Do we have the right to alter an entire planet? Could we accidentally wipe out any native Martian microbes that might exist? What if we mess up and make Mars even less habitable? Despite the challenges, The idea of terraforming Mars is thrilling. It's not just about survival, it's about expanding the horizons of humanity, pushing the limits of science and engineering, and maybe even preserving Earth's legacy by becoming a multi-planet species. The journey itself would teach us incredible things about our own planet, the origins of life, and the future of space exploration. So, could we terraform Mars? The science says maybe, but it would require technology we don't yet have, cooperation on a global scale, and patience spanning generations. Should we try? That's a question we'll have to answer together. But one thing is certain. The dream of turning the red planet green is one of the most exciting possibilities in the future of space exploration. And who knows, someday, the descendants of Earth might just look up at a blue Martian sky and call it home.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.